A given mass of gas occupies 2 dm cube at 300 Kelvin. At what temperature will its volume be doubled, keeping the pressure constant? Solution. This is a question that has to do with gas. We'll be applying the gas laws. And amongst the gas laws we have, the one we'll be applying here is Charles' law. This is because of the condition given, that is, the pressure is kept constant. And Charles' law states that the volume of a fixed or given mass of gas is directly proportional to its temperature, provided that the pressure is kept constant. So since that's the condition in the question given, that is a constant pressure, then this makes Charles' law to be suitable in attempting this question. So for Charles' law now, we have the equation to be V1 over T1 equals V2 over T2. This is the equation gotten from Charles' law, where the subscript of 1 and 2 refers to the initial and final values. So that is, V1 is the initial volume, T1 is the initial temperature, V2 is the final volume, while T2 is the final temperature. Meanwhile, the temperature T is calculated in Kelvin. So let's proceed. Now the next thing to do now is to write out the values given from the question above. So for V1, which is the initial volume of the gas, we have V1 to be equal to 2 dm cube. Then T1 now, we have T1 to be 300 Kelvin. For the final values, we need to understand that V2 is doubled. So now if V2 is doubled, that's 2 times V1, the initial value, which is 2 times 2, and that is just for the unit dm cube. Then the temperature is unknown, because the question says at what temperature will its volume be doubled. So now this is T2, sorry. So now V2 is 4 dm cube and T2 remains unknown. So to get unknown, which is our T2, we'll be making T2 the subject of the formula, that is the equation written above here. So we have T2 to be equal to V2 times T1 divided by V1. So let's substitute the values. We have T2 to then be equal to V2, which is 4 dm cube, multiplied by T1, that's 300 kelvins, divided by V1, which is 2 dm cube. So this gives us 1200 for the numerator divided by 2, then the unit Kelvin, and this is equivalent to 600, the unit Kelvin as well. So the final temperature of the gas is 600 Kelvin. So at 600 Kelvin, the volume of the gas will be doubled. Kindly subscribe to this channel and also click on the notification bell so as to get notified as soon as new videos are being posted. Thank you.